All right, today we're talking about 5.1, which is an introduction to something called trig ratios. So we're going to be working with triangles this entire chapter 5, and we begin with this concept. There are three different ratios that are called trig ratios, and you can see them labeled over here. One of them is called sine, one of them is called cosine, one of them is called tangent. And this is going to be brand new notation. This isn't something that you've seen before. So I've got a little chart up here at the top to help you visualize what it is that we're talking about, since this isn't something that you've seen. So the function of trig functions, I'm just reading right here in your notes, is you to input an acute angle in a right triangle and you get an output of a ratio of side lengths. That's a bunch of math language that doesn't make sense. So here's what it is broken down. This part right here is the name of the trig ratio, sine. What goes after the name of the trig ratio is an angle. So 20 degrees, 30 degrees, 40 degrees, 70 degrees, 80 degrees. It will always be smaller than 90, but you are going to have an angle right there. That's what this symbol represents. On the other side of the equal sign, you have a ratio of two sides of the triangle that we're talking about. And in this case, the sine ratio is a comparison of the opposite side compared to the hypotenuse. Now, I'm going to break this down for you. We're going to go through this kind of slow and just introduce these things piece by piece, and then we'll do some problems with them. So the three trig ratios, again, are sine, cosine, and tangent. And each one of those ratios represents a different combination of sides of a triangle. So if you look at the sine trig ratio, you are comparing the opposite side to the hypotenuse. If you're looking at the cosine, you're comparing the adjacent side to the hypotenuse, and the tangent compares the opposite to the adjacent. And then I've got a diagram so you can see what those look like. So I have a 90-degree triangle. So here's my 90. And then I have to label, to write these ratios, we have to label the sides of the triangles. And all of these sides are labeled based on where this symbol is. If that symbol was up here in the top left corner, my labels would be different, but it's in the bottom right corner. So the way these labels work is a cross from the 90 is the side that's called the hypotenuse. So across from the 90, you've got the hypotenuse, and that shows up on the bottom of the sine trig ratio and on the bottom of the cosine trig ratio. The tangent does not use the hypotenuse at all. Now, the opposite side, if I were to take an arrow and draw an arrow coming out of that angle and point it at the opposite side, that would be the opposite side. So this side over here is the opposite side, and it goes on top of the sine ratio, and it goes on top of the tangent ratio. And that just leaves one side of the triangle. So I've got this angle, and next to it is the hypotenuse and another angle. The hypotenuse is always going to be the hypotenuse. The other angle is what we call the adjacent angle, because it is adjacent, or the adjacent side, because it's adjacent to this angle. This angle is made up by this piece and this piece. The top one is the hypotenuse. The bottom one is the adjacent side. So that adjacent side shows up on top of cosine and on the bottom of tangent. Okay. Now again, if I were to change these labels, if I were to change my theta and move it over here, my sides would get new names. Well, I guess the hypotenuse always gets the same name, but now my opposite side would be over here. So this wouldn't be the adjacent, this would now be the opposite, which makes sense because my angle changed, so my sides are going to change. So here's an example over here on the right. So I have a For now, all you're worrying about is labeling the triangle and putting the pieces in the right place. That's where we're going to start. So it gives me the angle down here in the corner. We call that theta. I don't know what it is. It might be 60 degrees, 40 degrees, 30 degrees. I know that it's theta. That's the name for it. Now, to write the sine, cosine, and tangent ratios, I need to label my triangle. So I always label the hypotenuse first because it is the easiest one since it's a cross from the 90. Then I label the opposite side because it is a cross from my angle. So this would be the opposite side. And then the one that's left over is my adjacent side. So when I write these ratios, I'm going to use those numbers. The sine of theta, you put the opposite on top, you put the hypotenuse on the bottom. So I'm going to put 3 on top, and I'm going to put 5 on the bottom. The cosine, you put the adjacent number on top, you put the hypotenuse on the bottom. So I'm going to put 4 on top and 5 on the bottom. And then the tangent, you put the opposite on top and you put the adjacent on the bottom. And I'm going to write that as 3 over 4. So the sine of theta is 3/5. The cosine of theta is 4/5. The tangent of theta is 3/4. The comparison of those sides. Now here's why these ratios are so powerful. I've got a triangle. Hopefully you can see this pretty good. On the left, I've got 3 corners of a triangle, A, B, and C. I've got this 29-degree angle down in the bottom left that's labeled. And I can change that. I can change that angle to whatever I want. So if I change that angle to be 30 degrees, over here on the right, I have my ratios written down. So if you notice, the sine, I've got the opposite side, 0.96 on top. The hypotenuse on the bottom, 1.93. If I divide those, I get 0.5. My cosine, I write the sides and I get 0.87. The tangent, I write the sides and I get 0.58. Now here's what makes this so cool. It doesn't matter how big my triangle is. If I take my triangle and make it teeny, teeny, tiny, notice that even though the numbers in my fraction changed, sine is now 0.14 over 0.28, but it's still 0.5 when I simplify it. The cosine is still 0.87. The tangent is still 0.58. And it doesn't matter how big or small my triangle is, those ratios are always going to divide to be the same number if my angle is 30 degrees. That is really powerful math. That's something that we can use to solve millions of problems with triangles. Now, if I change my angle, if I change this to a 45-degree angle, then my sine and cosine and tangent change. My sine becomes 0.71, my cosine becomes 0.71, and my tangent is exactly 1. And again, if I change the size of my triangle, those numbers don't change. Even though the fraction numbers change, they'd simplify to equal the same answer. So we're going to use that fact to solve problems, all right? And here's how we're going to do it. We're going to give you a triangle. And instead of giving you 2 sides and letting you use the Pythagorean theorem, in this example, we give you x and 26, but you don't know the third side. But you know instead this angle on the inside. And using these tangent, sine, and cosine ratios, we can find this missing piece if I know the angle and one of the sides of the triangle. I don't need 2 sides of the triangle anymore. So here's how we're going to do it. I'm going to label the triangle first. So here's my 90 degrees. Across from my 90 degrees is the 26. So that is my hypotenuse. Now, my angle is down here in the left corner. Across from my angle is x, so that's going to be called opposite. The bottom side is the leftover adjacent side. So when I look at this triangle, I'm going to use 3 pieces of information. I'm going to use this angle. I'm going to use the hypotenuse because I know that it's 26, and I'm going to use the opposite side because that's x. That's what I'm looking for. So I'm going to write the trig ratios like I did above, but this time I'm going to put actual numbers in my ratio. So when I look at sine, cosine, and tangent, I'm using hypotenuse and opposite. So I'm looking for the ratio that uses hypotenuse and opposite, which is sine. So that means I want to use my sine ratio. So sin, after sin, we write the angle that it gave us, 42 degrees. Then I'm going to write my fraction. The opposite goes on top, so x is going to go on top. The hypotenuse goes on the bottom, so 26 is going to go on the bottom. So I've got sine of 42 equals x over 26. This looks weird, but if you type that in the calculator, it's going to give you, this is an actual number. So even though I don't know what it is, I don't care because my calculator does know what it is. So I'm going to leave that sine 42 together, and I want to get x by itself. Well, x is being divided by 26. The opposite of dividing by 26 is to multiply by 26, so that's going to go away. And when I multiply the left side, I want to multiply by 26, but I want to put it in the front. I don't want to put it after the 42 because I don't want the 26 and the 42 to get multiplied. I want the 26 and this entire thing to get multiplied together. So I end up with 26 sine 42 equals x. And again, I know this left-hand side looks weird. We don't care. You can type that in the calculator. You would type 26. There is a sine, cosine, and tangent button on both calculators. They're 2 rows above the 7, 8, and the 9. So you would just type that in your calculator, 26 sine of 42. You would hit enter. I'm using a calculator right here, and I need to make sure it's in the right mode. I'll show you that next time. So x is equal to, whoops, that's not what I want. I want my pen. X is going to equal 17.397 and a whole bunch of decimals. I'm going to stop at 3 decimals. So that side of the triangle is 17.397. What happened to my 7? That was a goofy one. Okay, let's try that again. New triangle. It's a 90-degree triangle. I know that this side is the hypotenuse. I know that my angle's up here, so across from my angle is going to be the opposite side, and then the one that's left over is the adjacent side. So this time, I've got the hypotenuse, I've got the adjacent, and I've got 73 degrees. So I look for this trig ratio with hypotenuse and adjacent, which is cosine. So I'm going to write down my ratio, cosine, and I always put the degrees after cosine. Cosine of 73 degrees equals, now this time adjacent goes on top, hypotenuse goes on bottom because that's what my formula tells me. Adjacent goes on top, hypotenuse goes on the bottom. So this one is a little bit different than the last one because the last one, x was on the bottom, x was on the top. So when I solve, this one takes one extra step to get x by itself, but it's a really easy step. So right now I'm dividing by x. So to get rid of dividing by x, I'm going to multiply by x because that's going to get it off the denominator and move it over here to the front. So now I've got x cosine 73 degrees equals 17. Well, x multiplied by cosine of 73 degrees, I can do the opposite of multiply and divide by the cosine of 73 degrees. So I end up with x equals 17 divided by cosine 73. So if you notice from where I started, this x and this entire thing just switch places, which is nice because I can type this into the calculator. I can take that 17 divided by cosine of 73, type it in my calculator. 17 divided by cosine of 73. These are not numbers you will ever memorize, so don't even worry about it. Equals 58.145. So my hypotenuse is 58.145. Oops. Nope, that's right. We're good. I thought I hit the wrong button, but I think we're good. So that side is 58.145 long. Okay, let's try a couple more. I know this is a little bit overwhelming because it's all completely new and foreign and weird. Just follow the steps, okay? This is a right triangle. It gives you an angle. I want to label the sides. So this is my hypotenuse. Across from the 55-degree angle is my opposite side, which means this is the adjacent side. So I want to solve for x. So I need to use adjacent. I need to use opposite because hypotenuse gives me nothing. That's not going to do me any good. And I want to use 55 degrees. So which ratio up above uses adjacent and opposite? That's going to be the tangent ratio. We haven't used this one yet. So I'm going to write the tangent of my angle, 55 degrees, equals the opposite goes on top, x goes on the bottom, and I want to get x alone. And in the last problem, we saw a shortcut where when x is on the bottom of the fraction, the x and this tan 55 just trade places. So I can move the x over here. I leave the 38 on top, and I put the tangent 55 degrees on the bottom. Now that only works when x is on the bottom, okay? When x is on the top, we've got to do it like this first example in the top left. So don't always switch the x. That only works when it's on the bottom. So in my calculator, I'm going to type 38 divided by the tangent of 55. I hit enter, and my calculator tells me that x is equal to 26.607. I know that side of the triangle. Okay, B. Let's start by labeling. My hypotenuse is across from the 90. My angle's up here at the top. The opposite side is x. And that means adjacent is over here. When I look at what I'm using hypotenuse, I'm using opposite, and I need 37 degrees. So opposite and hypotenuse go with sine. So I put, whoops, I don't want that. I want my pen. So I write the sine followed by the angle, 37 degrees, equals opposite on top, hypotenuse on the bottom. Now I railroad track to get x alone. The opposite of dividing by 11 is multiplying by 11. So I multiply by 11 over here, and I get 11 sine 37 degrees equals x. I plug that in my calculator. 11 sine 37. Hit enter, 6.619. If I round up, it's 6.612. Either way, it's close enough for me. 6.619 is going to be my opposite side. So if I needed to measure something in real life, I don't need two sides anymore to figure out the third side. I only need an angle and one side of the triangle, which makes some powerful real-world applications that we will do in a probably like 5.3, 5.4. We'll do some real-world applications of this stuff. So let's do the last one. Label the triangle. That's what we're going to do first every time. Across from the 90 is my hypotenuse. Across from my angle is my opposite. Whatever's left over is my adjacent. So I'm going to use adjacent, hypotenuse, and 61 degrees. So adjacent and hypotenuse is cosine. So cosine of 61 degrees. The adjacent goes on top. The hypotenuse goes on the bottom. Railroad track. to get x by itself. The opposite of dividing by 15 is to times by 15. So I end up with 15 cosine 61 degrees equals x. 15 cosine 61. Sorry, I didn't type these in before I started. X is equal to 7.272. So you know what that length is. And if you wanted to, now you could find the opposite side. Even though it doesn't ask for the opposite side, you could use the hypotenuse and the opposite and just call that, I don't know, y. Whoops, again, that's not what I wanted. I want a pen. You could call this y, and you could say the sine of 61 degrees equals the opposite y divided by the hypotenuse 15. Move the 15 over, and you can figure out what y is as well. Okay, practice problems. The first couple just want you to write the ratios. After that, you've got 9 problems where you are getting you're going to set up the trig ratio. So label the triangle. We can even write the steps right here for you. Label the triangle. Step 2, pick a trig ratio that matches the information you're given. Step 3, solve for x. Step 4, calculator. You're going to do that 9 times. The last problem gives you a story problem. It wants you to draw the picture, which is going to be a triangle, and it wants you to find the missing information. Come see me if you need any help.